Welcome to Cheap Controls. We make videos on things that we struggled with, hoping to help you so you don't. Consider subscribing and hitting that bell. We are adding content to cheapcontrols.com so you can download some extra documents used in this video.
In this video, I'm going to go over the Nextion Display connected to a Seeed ESP32-C6. I'll measure humidity and temperature, and I'm going to have some feedback between the ESP and the Nextion Display. Last week I had a video on the Shelly device, and then this week I've got a temperature device. I'm hoping to start tying it all together in the next couple weeks. I'm going to start by going over the interface that I have set up. Up here I'm going to show the temperature and humidity, and those measurements or those readings are going to be sent from the ESP, the Seeed, up to the Nextion Display. Now eventually we're going to get this to where it will turn something on and off based upon temperatures. So I'm going to have an upper limit and a lower limit over here. Now you'll notice that some of these fields I've given names, like this one is U text, in other words upper limit text and lower limit text. And then up here I have temp and humid. And these are just to make it easier when we look at the code, because there are some things that aren't going to change, like these text boxes, so those I've left alone. Now in order to start the feedback process from the ESP, I'm going to set the U text and the L text, the upper and lower text, from the ESP. So the limits aren't going to be set on the screen, they're going to be variables. And I have an upper and lower variable down here. Now these are number variables. Now I have these radio buttons, and the way I have them set up is if you select the up, you're affecting the upper limit, and if you have the low, then you're affecting the lower limit. And you can see the code I have. So in this case, if up, if this value is 1, then the lower value is 0. Because these are independent radio buttons and I don't want them both to be on at the same time. So if 1 is up, then lower must be 0. But if 1 is not 1, then I want lower to be 1. So it won't matter which one we hit, it'll toggle back and forth. And I have the same but the opposite down here. Now if you'll notice too on the Nextion, for those who haven't done much with this, with the if else, the formats is very important. You can't put the curly brackets up at the end of the if. It has to be followed. An else statement has to be in line with the curly bracket. Otherwise you'll get a compiler error. I'm going to show you how this works right now in debug. So when I click on the lower one, the upper one goes off. And if I click on this one repeatedly, you can see that it toggles. Now for the up and down, what I'm using is two buttons to raise and lower both the upper and lower limits. So if I select this upper one, then I'm going to raise and lower the upper limit. If I select the lower one, I'll raise and lower the lower limit. Now, as I said earlier on, we're not going to display the text, the limits over here. We're going to use these buttons to adjust the variables down here. And then as we adjust them, we're going to send the data to the Arduino or to the ESP, and then the ESP will reply and populate these upper and lower fields. And this is one of the ways we'll know that the ESP is connected. Now the way that I have it set up is I don't use the Nextion library. So when I send something to the Arduino, I have to do it in a certain format. And I always have a beginning delimiter of C:(C). So I'm going to start by setting up my send string, which is another variable down here, and make it equal to C:(C). And then if the up value is 1, or this one right here, then I know that I'm affecting the upper value. And I'll increment the upper value. And then I have to send a command to the ESP32. And the way I have it set up is all of my commands are 3 characters. The command lengths have to all be the same length. But you can make it 3 or 4 or 2 or whatever it is you want. But in my case, I'm setting it to be 3. So my string is starting with C:(C) and then UPR. Now if the lower was set to 1, it would go down to this else, and then it would increment the lower value by 1. But we have to have another if condition because we don't want the lower value to ever go above the upper value. So we're going to compare it to the upper value, and if it is above it, then we're going to set the lower value to 1 less than the upper value. And down here we would add LWR to the string. So up here we add UPR, and down here LWR. So then we're going to use the covax in both cases, upper or lower. And the covax takes a number and turns it into a string. And I have this other variable down here called temp string. So I have my send string, which is what I'm going to send to the ESP. And I have my temp string, which is where I can store variables as I change them back and forth. So we're going to turn the upper value into a string in tempstring.txt. And then out here, you have 2 more attributes that you have to put on. The length, which 0 is automatic, because I don't know the length. And then the format. And the format's going to be decimal. So that's 0, 0. And these are commas. Even though there's a dot between the operand value and the temp string and text, there's commas in the other spots. So once we have either one of these into the temp string, we're going to go down here and we're going to move the temp string. We're going to append it to the send string. And then finally, we're going to add a question mark to the end of the send string. And that's what I use as my ending delimiter on the string that I send out. So the total string, if it was going with the upper, would be C:(C), UPR, and then the temperature that we've adjusted it to, and then a question mark. And we do the same thing for the down, except for on the down, we've verified that the upper value cannot go below the lower value. So if the upper value is ever less than or equal to the lower value, we're going to set the upper value to equal to the lower value plus 1. Now the heat and the cool down here, we're going to get to that a little bit later. But this will be where we'll decide, do we want to be a heater? Do we want to be a cooler? Or maybe do we want to do both? Or maybe we don't want to do neither and just monitor the temperature. Now down here, the Arduino connection is another spot where we're going to look for feedback to see if the connection between the ESP, actually I have Arduino in here, but we're going to check between the ESP and the Nextion. And what I have is I have this field right here. And the initial configuration is going to be yellow background and saying checking. And that's what you see on the screen. So I'm going to have this watchdog timer over here, and I currently have it set to trigger every 2 seconds or 2,000 milliseconds. So every 2 seconds, something's going to happen. And in this case, we're going to look for a variable named WD. Now, you'll notice in this variable, there's no .val. And that's because I've assigned it up here in this Program S tab. When you make a variable up in this Program S tab, it has to be of type integer. And since you assign it over here, the Nextion Display knows it's always going to be an integer, so it assumes value. So over here I can just say if WD is equal to 2, then we're going to change that text. I'll go back to the display. We're going to change this to red, and we're going to make the print say error. If it's equal to 1, we're going to have it be the yellow state it is now, and the word's checking. And if it's 0, then we're going to have it be green, and we're going to say good. Also, if it's 1 or 0, we're going to have an increment, so it'll go to the next level. So we're going to have the ESP try to define this as 0, and every time the ESP sets it to 0, the Nextion will display it as green. But then after 2 seconds, it's going to go to yellow, and then after 2 seconds after that, it's going to go to red. And then that way, over time, if we lose connection to the ESP, this indication should also tell us something. That's the code for this. I'm going to go ahead and pull in debug so you can see this change, because we don't have the ESP hooked up. So, or this is in debug, it's not even on the live one. So when I run this now, you should see after 2 seconds this go to red. Oh, and I forgot to mention, I have a final state of blue. So if it's not 0, 1, or 2, which since on 2 it doesn't increment, but let's say it does for some weird reason, goes to 3 or above, it's going to change to blue and it will show the words issue on the display. You can see that it starts off yellow and then it changes to red, and it'll just sit there at red. And now I'm going to move on to the ESP and show you the code over there. When I work with the Arduino IDE, instead of having all my code in one file, I like to break it up into multiple files. And if you've seen my videos in the past, you're pretty familiar with this. And the way you can do that is the file folder itself has to be named one of the files. And you can see in this folder here, I have the HMI file that we're working on. And then I have the 207 prod, which is the name of the folder. And then I have this CC stuff, which doesn't pertain to this video. And then I have my delay and my input INO. And then when you go back to this, you can see that they form tabs up here. I did want to show you the device itself real quick. These ESPs, these Seeed Studio ones, are tiny. They're only a few pins. So they're real handy and kind of fun to work with because you can make small circuitries. And in this case, we're only going to be measuring temperature, so we only need one circuit on it or one input on it. So it should be fun for this test. I'm going to go over this code a little bit more than I do sometimes in videos, but so you can skip ahead if you want. But for the display itself, whenever you send a command to the Nextion, it has to end with 24 ones, like binary ones. I send it 3 sets of FF, FF, and FF, which is 24 highs. And then I name that my end care. So then I can just add it to whatever it is I send. So the name of it is end care. And then I also use a DFD variable, which is a data from display. And I initialize that to empty to start with. And then I also use an asynchronous delay in the code. So this way I can have something trigger every so often. And in this case, I'm having my delay length 5,000 milliseconds. So this delay is going to be set to trigger every 5 seconds. I'll have something happen. And these are something I put in almost every video that I make, these two items. I also generally use a nano. And so I use this include software serial.h, and that allows me a second serial port. So that way I can see the data coming through the programming port in the nano, but I can also see data, or I can also connect it to the Nextion display. But in this case, with this particular Seeed device, this ESP32C6, and I looked it up, it's also true with the RP2040. You can use a hardware serial.h library. And it's supposed to work a little bit better. The only thing I can't quite figure out is based on the pins that you use on the Seed, I would have guessed it should be serial UART2. But from what I've looked up, it's hardware serial UART0. Now, in order to keep my naming conventions the same from other videos I've done, I'm calling it serial 2, but you could call it whatever it is you wanted at this. And then I'm also using this DHT11.h library. I'm going to use a DHT11. It's only accurate plus or minus 2 degrees, but in this case I won't have to worry about using a float. I'm just going to use an integer. And I also put these two variables in here. I'm going to have an upper limit and a lower limit. I'm going to start it at 88 and 70. And then I have to create an instance of the DHT11, and I'm putting it on pin 0. And then a lot of times I have this pin set up as an output pin, but in this case I just blocked it off because the 13 is the pin for the nano. And then I'm just starting my serial 1 and my serial 2. And I'm setting them both at 9600 baud. In the loop, I'm only going to have 2 functions. If their serial 2 has data on it, in other words, if the Nextion has sent anything, I'm going to call this input function, and it's tied to this input INO. And then I have this asynchronous delay, and this is going to trigger every 5 seconds. And the milliseconds goes above the first asynchronous delay, which is 5,000. it will run this. And the first thing it's going to do is set this asynchronous delay is going to add 5,000 to it. So that way it won't run again until the milliseconds counts up another 5,000. And then we're going to run this delay function, and that's up in this delay INO. So in this delay, the first thing we're going to do is we're going to go to that DHT11 and we're going to read the temperature. And then I'm going to print it locally. I'm going to print the temperature in degrees C first. And then I'm going to take the temperature and I'm going to multiply it by 1.8 and add 32. That's how I personally changed C to Fahrenheit. And then I'm going to print it locally also. And then in serial2.print, I create the string that sends it up to the Nextion. And then after we do the temperature, then we're going to do the humidity. Oh, and we are writing this to that temp.val. If I go back to the Nextion, we're writing it up to here. So the temp and the humid. And then down here, we collect the humidity, read humidity, and we display it. And then we do the serial2print humid.val equal, and then the value plus that end character that we defined at the beginning. And then finally, in order to make sure that the connection, because we have that WD variable up there, we're going to serial2.print WD equals 0 plus the end character. That way we're continually setting that WD variable to 0. But our delay is 5 seconds. So we're going to set it to 0, and then the timer in the Nextion is going to go 2 seconds to yellow, and then 2 seconds to red. Well, that's 6 seconds, so there is a chance that this will see red or see an error state before this writes it back. And I've done that on purpose just so I can show you how that works. And now we're going to go over to the input. So whenever I see data on the serial port, I'm going to collect it one character at a time. And I'm going to collect that single character and I'm going to store it in the DFD. After I've collected 3 characters, or greater than 3 characters, I guess 4 here, greater than 3, then I compare the first 3 characters to C:C. So I know that if I don't see C:C, I need to erase the DFD and start over because I've got something's wrong in the string I'm collecting. So if the first 3 characters are not equal to C:C, I erase it. Otherwise, I go into this loop down here and I check things. And the first thing I look at in this else loop is if the last character is a question mark. Because once I see the question mark, I know I have my whole length. I should have the C:C, the lower or upper, a value, and a question mark. And once I have that question mark, then I can break it out. So I know my command is going to be 3 characters long, and it's going to start with the 4th character. And when you do a substring, first number in it, the 3, is 0 based. So it's the 4th character. The second number is not 0 based. So it's 4, 5, and 6. And I'm going to store that in my command. Now the value can be any length. So I know I'm going to go from my 7th character, and I'm going to go to the total length minus 1, because I don't want to get that question mark. I'm going to store that in my value. And then just for test, I'm going to print that in the serial monitor. So then after I've determined I have a good string, then I go down here and I look at the command. And if the command is upper UPR or LWR, I know that I have a command. And for this, I'm going to go ahead and print test command. I actually don't need the word test. And then I'm going to print the value. And actually, that should be UPR. Down here, I'm going to print command DWN. Should be LWR. And the value. And then I'm going to write the value back up, because remember on the display itself where I show the upper and lower values, I'm going to be sending that data from the ESP. So I do the serial2print, I do the utext or the ltext.txt equals, and then since I need to send quotes around the text value, I do the \quote quote plus the value. And then I do another quote, so quote \quote quote, and then I have to end it with the end character. And I send those values back up to the Nextion display. At some point, I'll also have to store this upper and lower into the values so that I can control something. And if you look back at this first page, this upper and lower limit. But we'll worry about that later. So for right now, what we have is we have the Nextion Display collecting data and sending it down. And then we also have the ESP collecting data and sending data back up. I'm going to show you it working on the display itself. Here's the display. I still do not completely have my shop set up, so it's a little dark right now. But you can see the display itself, and you can see that the limits are not populated. And that's because we haven't sent anything to the ESP so that it'll send it back to the upper. And the other thing is you'll notice the first time I push the button, I don't think anything will happen because it's probably in a weird state, and I have to get that exact command, that C:C, and the limit and everything right. So when I push this down button, you see that nothing happened. When I push it the second time, now we've got it. So now from here on out, we should get good commands. So I can go up and down, and I'm going to switch to the lower. And now if I go up, see, I can't go to 86. And if I go to this upper one, I can't go down. But if I go up to 87 and then switch back down, I should be able to go to 86. But you can see my current temperature is 60 degrees. It's kind of cold in here right now. So now you can also see down here, and we're getting the good, and then it goes to checking, and then we get that error. And it goes back to good. That's because it's taking 5 seconds for the Arduino or the ESP to reset that WD. So we need to change that at some point. I'm going to unplug the receive and transmit, and you'll see it will stay at red. And so it's working just like we would expect. And there, I plugged it back on, and we're back to good. Now let's go back to the Arduino, and we'll change our timing of the delay. Which is on my main page. If I change this to, let's say 3. So 3 should go to yellow, but we really should never see red. So you can see it's good, then it goes to yellow, back to good. So in this video, at this point, we have a device that can read temperature and humidity and could conceivably control something at a certain temperature at an upper and lower limit. You can see I unplugged it. Let's go ahead and set this back. And also in the video, we can see that the connection doesn't break between the two. So we know that the Arduino or the ESP and the Nextion are connected. And if that ever fails, if that connection ever breaks, we would get an indication that it's broken. And that's good to know, because if you have something controlling something important, you would want to know if that connection were broken. Now the next question is what device should control the heating and cooling relays? Should the Nextion control it with its internal GPIO pins, or should the ESP control it with an output on it? And I'm going to leave that up to comments. So next week when I make the next video, I'm going to add that connection to turn something on and something off. And I want to know what people really would rather it be. Would it rather you use the GPIO pins or the ESP? Now, the device that I'm using for the Nextion is a discovery series. It doesn't have GPIO pins. So the other thing I would have to do is switch it over to an enhanced or an intelligent display, which I'm willing to do. And then I'll also show how to import that into, how to take this sketch or this HMI file and load it into a different display, because you can import the code into another display. And I've had people ask me about that. So if you want the ESP to control it, we'll do it that way. If I get enough comments that say they want the Nextion, we'll do it that way, and then we'll also upgrade the display. Or not upgrade the display, but take the code from this one and load it into a different display. Oh, and for an update on the animation video, I'm still trying to look into how to get a GIF to load directly into a display. And I have got something I'm working on. I'm fairly hopeful. I'm going to work on it a little bit this weekend and see. It's still probably a couple weeks away, but it is coming. And even if I can't get it going, I'm still going to do something to show you what I did to attempt it, whether it makes it or it fails. So I'm looking forward to making that video too, because sometimes when I don't know what's going to happen, it makes the videos a little more fun.
Well, that's about it for this video. If you like what you saw, consider giving me a thumbs up, and also consider subscribing to the channel. Thanks for watching.